Minasan, konnichiwa, Zamurai Engineer desu. In this video, let us continue our discussion from last week about principles of reinforced and pre-stressed concrete. We are now on module 1.01, applications and use of RPC. In short, RPC. We are talking about reinforced and pre-stressed concrete. So I'm your, again, Professor Dr. ZANTUA, a Bachelor of Engineering graduate from Polytechnic University or PTU, Japan, as a government scholar of Japan. So let us start with the principle of reinforced and pre-stressed concrete objectives. So this course would provide us with fundamental concepts, principles, and theories in the structural strength analysis and design of what? Plain, reinforced, and pre-stressed concrete elements in an structure. Parts of this course are the following, which we are now starting to be right on number 1. And under this first part, we have several subtopics. We are now currently on the application. Okay. At the end of this video, the student must be able to understand the advantages of reinforced concrete. You should be able to understand also the disadvantages. Why advantages and disadvantages are the information we need in order to appreciate the application of this material or component. Okay? And lastly, we should be able to identify CE structures for which the use of reinforced concrete is better than structural steel. So, as you can remember, we already talked about the application and usage of structural steel. Okay. So, in order to compare to other construction material, let us again start with discussion on advantages of concrete and reinforced concrete as structural material. So this material is having a very high compressive strength. This is actually the most important characteristic of concrete. Okay? It has a high resistance versus fire and water. Another very good characteristic, because we would like our occupants inside a structure to be safe against fire and water. So having a material, having a component with so much resistance to offer against these environmental and risk factors, of course, we could say that it is really an advantage. Number 3, there are a wide range of application for this material, for this component. And next, we have only simple skill requirement in order to be able to use this in a construction setting. As you can see, there are plenty of skilled worker, but more of non-skilled worker. Okay, so those skilled worker are the supervising ones, supervising how those non-skilled workers do their job in order to accomplish the task of putting on the reinforced concrete structure. Okay? So there are processes behind it. So let us just discuss more detail on this later on, and just continue with number 5. Availability is an advantage. Not only it is available, but it is available elsewhere, locally. So what can you say about the availability of what? Sand, gravel, right? Those things. Anywhere, I think anywhere in the world, there are plenty, abundant supply of those materials. Okay? And therefore, they are available. And economy, because of availability, economy comes hand in hand with it. Also, compared to other construction material, of course, economy. Okay, how much can you pay for sand? How much can you pay for a gravel, which are naturally available? Okay, so therefore, the cost of those things, of those materials, which are having the most quantity in a reinforced concrete element. So there is a very small quantity of steel. There's very small quantity of cement. Okay, most of the quantities came from either sand or gravel. Okay. And number 7, rigidity. Of course, it has a high compressive strength and comes hand in hand with it. It is rigid. It's a rigid material. Okay. And next, low maintenance. So as soon as you put it on, it cures, it dries, it is now prepared to be used. Okay. So it almost always have what? Zero maintenance. Okay. So very limited necessity for maintenance. It has a long service life. So even if an engineer who designs something, a structure, for example, that would last 50 years, the concrete materials will last longer than that. Okay? So even if you design a structure for 30 years, the concrete components would last more than that. Okay? So usually it lasts more than expected. And throughout history, we have plenty of example of this material that still stands up to this day for what? Hundred of years, century, more than 50 years. Okay? And number 10 is appropriate for footings application, floor slab application, basement walls, piers, and the like. These things are those components of a structure which are in direct contact with the environment. And environment, not only environment, but moisture, water, possibility of seeping in an amount of water. So because of that, we need a material that would stand up against these environmental factors that would affect our structure negatively. So therefore, as a material, reinforced concrete is a good example of this thing. Okay? So next we have reinforced concrete known to be casted into a variety of shapes and sizes. It's very easy. Just you just need to what? To make a form so that the liquid cement or the wet cement could be poured into it and wait for it to dry. Then after drying, you now have the desired shape. Okay, so you don't need so much equipment, machinery in order to cast it into variety of shapes. For example, you are using steel. You want steel to be casted into to a complicated shape. You need, of course, equipment, device, or very rigid form or die, okay? So that you can pour a liquefied steel, then also let it dry on that condition, then will be casted into shape. But compare the difficulty, okay? The difficulty. And next, this material, reinforced concrete, requires cements and steel in small quantities. I already said this, but again, I have to list it down as another advantage. Okay, because what? Why? Because this material, this specific materials, are common materials in the construction, but they are more expensive than others. Than what? Sand, gravel, which are the materials occupying bulk of the quantities required in a RC component. And after which now we are ready to talk about disadvantages. So let us now take a look, because every material have advantages and disadvantages, and taking a look on the disadvantages will also enable us to have an insight on what is specific application we cannot use this material. Okay, reinforced concrete has a very low tensile strength. This is the top disadvantage of this material. Low, very low tensile strength. Okay. Number two, it requires use of complicated formworks and false work. As you can see on the picture on your right side of the monitor, you have what? A construction work with formworks being done. Okay, 90% of what you are seeing on that picture is actually formwork and false work. We will have a special video discussion on the difference of what really is a formwork or what really is the false work. As of now, let us say that this structure that you are seeing right now, so I am guiding you. So these are the structure, the arcing structure, and the supporting ones there. So including those plates, okay, that is partially covering the roofing portion, the top portion. They are all what? Formworks and or false work. Okay. And number three, we have a material with low strength per unit weight. If we compare the strength of the material per unit weight, this material is a very low. compared to other types of material like steel. Okay, so meaning to say, if you compare this to other material like steel, you would expect with the same load, okay, we need what? Too much weight of RC component or concrete component in order to resist the same amount of load. Okay? And it is related to number 4 with low strength per unit volume. So it has a low strength per unit weight and also low strength per unit volume. Therefore, we are not only looking into a component that would give us a heavy weight in terms of comparing with, for example, for steel against the same amount of load, you should expect what? Bulkier structure. Okay, we could expect huge structure. For example, column, post, beam. We should expect heavier columns, heavier beam, heavier post compared if we are using steel. Okay, it's not just heavier, it is also bulkier, meaning the dimension. The dimension of the components are bigger. Okay, that's what we mean. No, it's not only heavy, but also bulky. Okay, and next we have the concrete property having varying characteristic due to proportioning, mixing, placing, and curing of the concrete mixture. So during the the construction process, okay, we cannot control it very precisely. We cannot control the characteristic of this component accurately as compared to steel, okay? Because of differences in proportioning. Even different person will make the mixing of concrete mixture different from one another. Okay? So, and also the workers, even skilled workers, will have differences in placing this material to the formworks, to the slab, to the decking, okay? Okay. And the environment also affects us during the curing process, the drying out process. Okay? So, and those things introduces differences, varying characteristics, and that is not a good way to control something. We want our material, we want our system, we want our components to be controlled in our desired manner. So if we cannot do that, therefore, we will rely on the result, then afterward testing if that result would satisfy our requirements. So there are so much of that, okay, when we are using this type of material. Next, we have the problem of shrinkage and creep. As we use this material for a long time, it would shrink and creep. Sometimes shrinkage will appear as soon as the concrete mixture started to dry. Okay, just starting the curing period, we may be able to observe shrinkage. As you can see on your picture, the right side of your monitor, we have shrinkage. picture of shrinkage, there are what? Noticeable cracks. Okay, these cracks could be noticeable as soon as the drying starts. And creep is more on as you use the structure for a long time, 5 years, 10 years more. So you will notice what creeping of this material. We will also have a very specialized video on this too, so that we can explain further the difference between shrinkage and creep. Okay, let us have a challenge question right away. In this question, we are going to tackle problem about non-liquid admixture. What is an admixture? Admixture is a chemical component that is added on the mixture of concrete mixture so that it could change the characteristic of the resulting output. Okay, so we could create, we could design a better characteristic, a desired characteristic out of the ordinary, supposed to be ordinary concrete mixture by adding admixture. Okay, so that most of the construction companies or engineers would specify admixture to be added. Okay, so there are two types. We have liquid and non-liquid admixture. So non-liquid meaning it is usually in the form of particles or powder. Okay, so a non-liquid admixture is packed in how many kilogram per container? So it is in terms of container. So how many kilogram is one container? 20, letter B, 25, letter C, 15, letter D, 10. So guess your answer or research your answer and comment your answer on the comment section below. So let us continue. After having been discussed the advantages and disadvantages, we are going to talk about the application of reinforced and pre-stressed concrete. RC is a dominant structural material in engineered construction. What do you mean engineered construction? There are constructions that are not engineered, meaning there are no plans, there are no engineering plans, just what trial and error, being supervised by skilled workers, but do not have scientific process, okay, applied into those construction, operation, and management. Okay, these are used in the following. So application of RC are what? Number one, buildings. These are the main application because it provides shelter for occupancy of human beings. Okay? Tunnels, drainage. Okay? So you will notice tunnels and drainage are susceptible to what? To environmental condition with moisture and water content greatly affects this application. So what type of material would be the best in this condition? Of course, reinforced concrete or concrete. Okay, tunnels and drainage. Okay, underground structure. Another one, water tanks, wind turbine, foundation. So these are directly in contact with the weather. Again, moisture are always there. Pavements also, not only moisture is there, but in addition, heavy loads are constantly or generally moving over this structure. Okay, retaining wall, special structure, or we have what, lateral force of soil. Okay, towers. So these are more or less different specialized structure. Okay, that would have so many different applications in real life. Okay, so there are several towers, Wi-Fi towers, communication towers. Okay, mast. Okay, tower mast and so on. Okay, and we have offshore exploration. So again, water is the main enemy of this application. 11 production structures. Okay, so it's 12 irrigation facilities, 13 dams, 14 bridges, and 15 structures in ships. Even those ships, but we are talking of very large ship, for example, aircraft carrier, wherein the ship has what? The the top component with pavements for what? Incoming and outgoing aircraft. That's why it is called aircraft carriers. And those pavements are usually by concrete or reinforced concrete. Okay. So as you can see, we have some of the pictures here. Okay, building, pictures of building being constructed, and with cranes helping the mobility of the material. Okay, the foundation, wind turbine foundation, installed at Invenergy's Raleigh Wind Energy Center in Ontario, Canada. So you can see the footings, the foundation is actually the size of the foundation alone. One single foundation is already a size of a residential house. Okay, and we have a bridge, which is what we call St. Anthony Falls Bridge in Minneapolis, Minnesota, with features 504 feet. Okay, 504 feet is about 150, 160. Okay, 160 meters, something like that. Okay, 160 meters. Okay, mean span, the span. Okay, the mean span is 160 meters. Okay, that is a great span. Okay, long span. Okay, so again, our next challenge question for this video, we have now the liquid admixture type. Liquid admixture is packed in how many liters per container, except, okay, 4 liters, 20 liters, 50 liters, 200 liters. Okay. And that's all for this video. Please like, share, and subscribe on our channel so that you can be notified on each and every video in the future. Okay, so again, this is Dr. EYPEI, Preaching Engineering for Nation Building.